tangent to the curve y equals x cubed minus 9x squared plus 24x minus 12 at a point A is parallel to the line y equals 2 minus 3x. We're required to find the equation of the tangent at A. Okay, it's a good idea to label these curves f of x and g of x. It just makes working with them far easier than having y equals. So f of x equals x cubed minus 9x squared plus 24x minus 12, and g of x is the line 2 minus 3x. Now, we're required to find the equation of the tangent at A. So the tangent to the curve f of x at point A is parallel to the line y equals 2 minus 3x. So let's just start with keyword parallel, right? Tangent is obviously a straight line. So when two straight lines are parallel to each other, we know that the two gradients of those lines, or the gradients of each line, the gradients of those lines are equal. So from g of x, just write this in standard form. G of x is minus 3x plus 2. The gradient of this line, let's call this gradient 1, is the coefficient of x, which is minus 3. Now, the tangent to f of x is parallel to g of x. In other words, the gradient of the tangent to f of x is also going to be minus 3. Now bear in mind, to find the equation of a tangent, we're required to find the equation of a straight line. So we'll call this tangent h of x. So h of x equals mx plus c. Let's call that gradient 2, m2, because we know that the gradient of the tangent, so the gradient of h of x, is equal to the gradient of g of x. So because we were told that the tangent is parallel to the line y equals 2 minus 3x. So h of x is therefore minus 3x plus c. We know that it's minus 3. Just to reiterate, is because h of x is parallel to g of x. So we know that the gradients are equal. Now to find the equation of h of x, we need a point that lies on the tangent. Now that point is point A. We're given that the tangent to f of x is at point A. Now, we don't know what the coordinates of A are. We're going to have to determine what they are. We are told that the tangent to f of x is parallel to the line g of x. Now, we know from f of x, if we differentiate f of x in first derivative function, the gradient function, f prime x, gives us the gradient of the tangent to a curve. So differentiating f of x will give us 3x squared minus 18x plus 24. This expression, 3x squared minus 18x plus 24, represents the gradient of a tangent to f of x. Now, we know that the gradient of the tangent to the curve at A is minus 3. We just determined that. So we know that f prime x has a value of minus 3. So we can say 3x squared minus 18x plus 24 equals minus 3. And we can solve for x now. 3x squared minus 18x plus 27 equals 0. Divide through by 3. X squared minus 6x plus 9 equals 0. Factorizing that gives us x minus 3 times x minus 3 equals 0. It should not be surprising that we only get one value of x here. That's because we know that we have a tangent at the point A. So this value of x equals 3 represents the x coordinate of the point of contact. So to find the point of contact, we're going to sub 3, x equals 3 into the curve. So we're going to, in other words, evaluate f of 3, which is 3 cubed minus 9 times 3 squared plus 24 times 3 minus 12, 27 minus 9 times 9 is 81 plus 72 minus 12, that equals 6. So point of contact is the point 3, 6. We now have all the information that we need to find the equation of the tangent at A. 3, 6 is the point A, so we have the point of contact, and we've got the gradient of the tangent because we knew that the tangent is parallel to the line g of x, which has a gradient of minus 3. So we can just sub this into y equals mx plus c. You can use the equation y minus y1 equals m times x minus x1. It's far quicker to use this because we substitute the point 3, 6 and the gradient at once into this equation, and it'll give us the equation of the tangent. Alternatively, if you don't like that method, use y equals mx plus c. So 6 equals minus 3 times 3 plus c. 6 equals minus 9 plus c. C equals 15. So y equals minus 3x plus 15. And this represents the equation of tangent to f at the point 3, 6. We're just going to use y minus y1 equals m times x minus x1. It doesn't make a difference. We're just going to do both in case if you prefer using that. So y minus 6 equals minus 3 times x minus 3. Y minus 6 equals minus 3x plus 9. Y equals minus 3x plus 15. And surprise, surprise, we get the same equation. The curve has equation y equals a half times 4x minus 3 to the minus 1. The point A on the curve has coordinates 1, a half. Find and simplify the equation of the normal through A. Okay, so let's just start with the fact that we're looking for the equation of a normal. A normal is a straight line, so it's defined by y equals mx plus c. A normal is perpendicular to a tangent. What that means is that the gradient of the normal times the gradient of a tangent equals negative 1. This is the condition for two perpendicular lines. So to find the equation of the normal through A, we are going to need to first find, well, to find the equation of a line, we need to know the gradient of the line and one point that lies on that line. Whether that line is normal or tangent is irrelevant at this point. We need to find the gradient and the gradient of the line and a point that lies on the line. So to find the gradient of the normal, we are first going to have to find the gradient of the tangent to the curve at A. From that, you can find the gradient of the normal. We also need to know a point that lies on the normal, and we are told that the point A on the curve has coordinates 1, a half, and we are required to find the equation of the normal through A. So we've got our point, right? So we just need to find the gradient of the normal. So to find the gradient of the normal, we're first going to find the gradient of the tangent to the curve at the point A. So we're just going to call this, let's write down the curve, y equals a half times 4x minus 3 to the minus 1. It's just a personal preference to work with f of x notation as opposed to y. Equals, so f of x is a half times 4x minus 3 to the minus 1. Now f prime x represents the gradient of a tangent to f of x. So differentiating f will give us minus a half times 4x minus 3 to the minus 2, and using the chain rule we have to multiply by the derivative of 4x minus 3, which is 4. So just tidying that up gives us f prime x equals minus 2 times 4x minus 3 to the minus 2, and an even better way to write this is as a positive power, so it's minus 2 over 4x minus 3 all squared. Okay, this expression here represents the gradient of a tangent to f of x, any tangent. Now, to find the value of a specific gradient of a specific tangent, we are going to substitute the point A in. We only need the x value, x equals 1, so because that is the point of contact between the curve and the tangent. So f prime 1 will be minus 2 over 4 times 1 minus 3 squared, and that equals minus 2. That'll be 4 minus 3 is 1, or squared is 1. So f prime 1 will just be minus 2. Minus 2 represents the gradient of the tangent to f at the point 1 half. Okay, we now have the gradient of the tangent to f at the point a 1 half. We need the gradient of the normal, so the gradient of the normal times the gradient of the tangent equals negative 1. The gradient of the normal is therefore just the negative reciprocal of the gradient of the tangent, so it will be positive since the gradient of the tangent is negative and the reciprocal of 2 is a half. So we have the gradient of the normal and we have the point a1 a half. So we can now substitute that into y equals mx plus c to find the equation of the normal. So a half equals a half times 1 plus c. A half equals a half plus c. C is therefore 0. Therefore y equals a half x. This now represents the equation of the normal to f through point A. And we're going to illustrate this as well. The curve, the red curve, which is f of x, the tangent is the black line, which we'll just call g of x, and the blue line is the normal, which we'll call h of x. And the tangent is perpendicular to the normal, and we have the point A over here, which is 1 a half. Next, we're required to find the x coordinate of the point where this normal meets the curve again. So to find, anytime you want to find points of intersection, you equate two functions to each other. It's as simple as that. So we have y equals a half x, which is the normal, and y equals a half times 4x minus 3 to the minus 1. That is the curve. So we're simply just going to equate these two functions now and solve for x. We can divide both sides by half to simplify the equation. So 4x minus 3 to the minus 1 equals x. Writing this in a form that we can work with, 1 over 4x minus 3 equals x, and multiplying both sides by 4x minus 3, 1 equals 4x squared minus 3x. Now we have a quadratic, which you're going to solve. So we're first going to put this into standard quadratic form by taking all the terms over to the one side and having the right hand side equal to 0, but also having it in ax squared plus bx plus c form. So 4x squared minus 3x minus 1 equals 0. We can now factorize and solve. So we'll have 4x and x, 1 and 1, 4x plus 1 times x minus 1 will give us the factors for the quadratic. So x equals minus a quarter or x equals 1. The fact that one of these x values is 1 should not be surprising, because the curve and the normal intersect at the point A, which has an x coordinate of 1, a y coordinate of a half. But what's important here is that A's x value is 1. So this is clearly the point 1 a half. In other words, the normal is going to meet the curve again where x equals -4. Now, the question asked us only for the x coordinate, so this is where the question stops, ends. But just for completeness sake, we're going to find the point where the normal meets the curve again. So we're going to substitute -1/4 into, well, in this case, we're going to substitute it into, you can substitute it into f of x, but it would be far easier and simpler to just substitute into what I think we call the normal h. So I'm going to substitute 1/4 into h of x. The equation of the normal is y equals 1/2 x, so it's 1/2 times -1/4, which is minus an eighth. So if we call this point B, then point B will be -1/4 minus an eighth. And B is the point where the normal meets the curve again. So again, we can illustrate this graphically. So we have the point A, which is 1/2, and the normal, h of x, meets the curve again at the point B, which is -1/4 minus an eighth. The diagram shows part of the curve y equals 1 minus 2x minus 1 minus 2x all cubed, intersecting the x-axis at the origin O and at A 1/2, 0. The line AB intersects the y-axis at B and has equation y equals 1 minus 2x. We're required to show that AB is a tangent to the curve at A. Okay. Without getting too much into the question, showing that AB is a tangent, the fact that they are mentioning the word tangent and they've given you a curve, you should automatically be thinking about finding the gradient of a tangent, which you're going to do through calculus, through differentiation. So the first thing we'll do is we're going to call f of x, or rather call the curve f of x. So f of x equals 1 minus 2x minus 1 minus 2x all cubed. We're now going to find f prime x, because f prime x is going to give us the gradient of a tangent to f of x. The fact that we're looking for a tangent to the curve at A, and we know the coordinates of A, means that once we get the gradient, we can then find the equation of the tangent. And we're required to show that AB is the tangent. So we're just really going to be showing that AB has this equation. So essentially, we're just finding the equation of tangent to the curve f at A and showing that it equals, that it's defined by y equals 1 minus 2x. Okay, so finding f prime x, the gradient function, the first derivative of f of x, gives us minus 2 minus 3 times 1 minus 2x all squared. And using the chain rule, we have to multiply by the derivative of 1 minus 2x, which is minus 2, and equals minus 2 minus 3 times minus 2 is plus 6 times 1 minus 2x all squared. F prime x, this expression here, represents the gradient of a tangent to f. If we want to know the value of the gradient of a specific tangent, we need to know the point of contact, which we know is A. They've told us we're required to show that AB is a tangent to the curve at A. So we've got the point A 1/2, 0. So now we're going to find the value of the gradient of the tangent to the curve f at A. So we substitute 1/2 in for x into the gradient function. So it gives us minus 2 plus 6 times 1 minus 2 times 1/2. That is all squared. So that's minus 2 plus 6 times minus 2 times 1/2 is minus 1. So I have 1 minus 1, which is 0. So this whole thing will just be 0. So the gradient is minus 2. So the gradient of the tangent is minus 2, and the point is 1/2, 0. So just coming up here, we're now going to substitute these values into y equals mx plus c. So 0 equals minus 2 times r half plus c. 0 equals minus 1 plus c, and therefore c equals 1. Therefore y equals minus 2x plus 1, which is this equation over here. It's just written slightly differently. We still have minus 2x minus 2x plus 1. This equation here is just written with a constant first, but if you wrote it with the variable first, it would be y equals minus 2x plus 1. So therefore, we have just shown that AB, the equation of AB is y equals 1 minus 2x, or y equals minus 2x plus 1, and we've just determined the equation of the tangent to f at A, which is y equals minus 2x plus 1, which confirms that this equation, which just shows that AB is in fact the tangent to the curve f at A. The diagram shows part of the curve y equals 2 times 3x minus 1 to the minus third, and the lines x equals 2/3 and x equals 3. The curve and the line x equals 2/3 intersect at the point A. We are required to find the equation of the normal to the curve at A, giving the answer in the form y equals mx plus c. Okay, again, just to simplify matters, we're just going to call the curve f of x. So f of x equals 2 times 3x minus 1 to the minus the third. The fact that we're required to find the equation of a normal, we are first going to need to find the gradient of the tangent. From the gradient of the tangent to the curve at A, we're going to then determine the gradient of the normal, and from that we can find the equation of the normal because we know the point A, or at least we can work out what the coordinates of point A are. We don't know at this point what they are. We're going to do that by equating the line x equals 2/3 to the curve f of x, because that vertical line x equals 2/3 intersects the curve at A. So f prime x equals 2 times minus a third, so minus 2/3 times 3x minus 1. Minus a third minus 1 is minus 4/3, and then we multiply by the derivative of 3x minus 1, so we times by 3. Just cleaning that up will give us minus 2 times 3x minus 1 to the minus 4/3, and an even better way to write this is with a positive power, so it's minus 2 over 3x minus 1 to the 4/3, which is better written as minus 2 over 3x minus 1 to the power of 4, and we take the cube root of that. The reason I'm writing it in this form is so that we can easily determine the gradient of the tangent to the curve at the point A. Now, at point A, the x-coordinate of A is 2/3. Every single point on the line x equals 2/3 has got an x-coordinate of 2/3. What differs is the y-coordinate of every point that lies on that vertical line. So A is the point 2/3 y. We're not going to worry about A's y-coordinate just yet. We just simply now want to find the value of f prime 2/3. In other words, the value of the gradient of the tangent to the curve at A. So f prime 2/3 is minus 2 over the cube root of 3 times 2/3 minus 1, that's to the power of 4. So it's minus 2 over the cube root of 3 times 2/3 is 2. 2 minus 1 is 1. 1 to the power of 4 is 1. So we have minus 2 over the cube root of 1 is just going to be minus 2. So this is now minus 2 is the gradient of the tangent to f at point A. Now, the gradient of the tangent to the curve at A is minus 2. Therefore, the gradient of the normal to the curve through A will be the negative reciprocal of minus 2, which is going to be a half. Now, to find the equation of the normal, we are now going to need to know what the y-coordinate of point A is. So to do that, we're going to substitute A's x-coordinate 2/3 into the curve f of x. So f of 2/3 equals 2 times 3 times 2/3 minus 1 to the power of minus the third. That's 2 times 3 times 2/3 is 2. 2 minus 1 is 1. So that'll just give us 1 to the minus third is still going to be 1. So that means that f of 2/3 equals 2. In other words, A is the point 2/3 2, and the gradient of the normal is a half. And we can now substitute these into y equals mx plus c to find the equation of the normal. So 2 equals the gradient a half times x, which is 2/3 plus c. 2 equals the third plus c. C is 2 minus the third, which is 1 and 2/3, or 5/3. And it's better to write it as 5/3. Therefore, the equation of the normal is y equals a half x plus 5/3. We don't have to manipulate this to put into any other form because they wanted it in standard form y equals mx plus c. So y equals a half x plus 5/3 is the equation of the normal to f through point A.